In this video, we're going to identify vertices, foci, and asymptotes of a hyperbola from an equation. So let's find the vertices and foci of the hyperbola below. So the first thing I want to notice is that the x term comes first here. And so this is how you're going to tell whether or not your hyperbola opens to the left and to the right or opens up and down. So if the x term comes first, we're going to say if x term is first, then we would say that that opens left and right. And then if y term is first, then it's going to open up and down. Now that's important because that kind of tells us, when we look at this, we see the x term is first. It tells us it opens left and right, which tells us where our transverse axis is. So if we draw this hyperbola, it would look like this, opening left and right, and our transverse axis would be right here, the one that I just drew. So we'd have two vertices, and then our foci would be outside of those two spots. Okay, and this would be foci. One on each side, by the way. So that helps us figure out how to get those coordinates. So once we know the center, which in this case, the center for this, because we don't have any like minus h or minus k values, the center is 0, 0. So when we go to find our vertices, all we need to know is the distance from the center to the vertice is going to be this a distance. And then the distance from the center to the foci is going to be this c distance that we're going to come up with here in a second. Now, these are always written as x squared over a squared minus y squared over b squared is equal to 1, or they will flop the y squared and the x squared, but a squared will always be in the left fractional spot here. So that tells us that a squared is equal to 16 and b squared is equal to 36. If I square each side here, I get a is equal to plus and minus 4, and b is equal to plus and minus 6. So when I want to find my vertices, what I'm going to do is I have to add to the x value, right? The y value is not going to change, but the x value has got to be added. So I'm going to have my vertices be 0, and then I'd have plus 4, comma 0. And I would also have 0 minus 4, comma 0. So I end up with 4, comma 0, and negative 4, comma 0 for my vertices. Now my foci, I've got to come up with that from this equation. C squared is equal to a squared plus b squared. Now this is not the Pythagorean theorem. This is for hyperbolas, and it's just a little different than the ellipses. If you remember from ellipses, we had c squared equals a squared minus b squared here. So this is for hyperbolas, and we would say that c squared is equal to a squared, which we already know a squared to be 16, and b squared to be 36. So we can take the square root of that. C is equal to the square root of 16 and 36 is 52. And we can write that as c is equal to root 4 times root. If I divide this by 4, I get 13. So I end up with c being 2 root 13. So my foci then are going to be, again, we have to add to the x value for each of those. So I'm going to say foci are going to be 0 plus 2 root 13, comma 0, and then 0 minus 2 root 13, comma 0. So we end up with 2 root 13, comma 0, and negative 2 root 13. 2 root 13, comma 0. So our solution here, if we're going to pick one of these, we would have the fourth slot down, plus minus 4, comma 0, and plus minus, it'd be this one here.